There we go. So how do we do this? So these are notes on, this is, you can call this section, what is this? 5 point something, 4 point something. It's going to be the second derivative test, the second derivative test, and curve sketching. How do we draw graphs from derivatives? How do we draw derivative graphs from functions? And what do these derivative tests tell us? That's our goal. What do these derivative tests tell us? How do we get information from the graphs? Again, conceptually, this is going to be challenging to picture what's happening from these curves, but I will do my best to lead you through it. So let's see, where do we start? What we know, recall what we know. In the first derivative, we know when f prime of x is greater than 0 or positive, when the derivative is positive, what do we know about the graph of that situation? What is f of x doing? When the derivative is positive, what is the graph of f doing? Right? Let's talk about what we know about our first derivative test, right? Our information about the first derivative. What do we know from the first derivative? If the derivative is positive, what is the graph of f doing? F of x is doing what? Increasing. Thank you, Stephanie. Yes, f of x is increasing. So to look at this graphically, if f prime, let me do the derivative in red. If the derivative is anywhere up here, like how do I draw this? Anywhere, like if the derivative is up here, or anywhere in the positive section, right? If the derivative is positive, if the f prime graph is in this area here, if it's positive, right? If the f prime graph is in the positive area, then we know that f of x, graphically, what's happening with f of x, is let me do f of x in black, f of x is increasing. Right? If f prime is in the upper positive area, right? If f prime is in here, then f is increasing. Look at this though. F can be in the negative section. It doesn't matter as long as it's increasing. Graph is growing. Could be growing like this. Could be growing like this. It's increasing either way, right? We have these two kind of different ways of increasing. It's going up. It's going up, right? Our graph is increasing if f prime is in this positive zone. If f prime is less than 0 or negative, then what do we know about f of x? F of x. So if f prime is negative, then we know that f is decreasing. Yeah, decreasing, exactly, decreasing. So if the derivative graph, if f prime is in this area below the x-axis, then f of x is decreasing like this, or maybe it's decreasing like this. We know it's going down. So this is what we know about the derivative. Last option, if f prime is equal to 0, what is happening with f of x? If f prime is equal to 0, so now our derivative is f prime is on the x-axis. At those spots, what is f of x doing? What is f of x doing when the derivative is equal to 0? F of x is what? The derivative is equal to 0. What is f of x doing? Is it increasing? It's not increasing. Is it decreasing? No. What are your what other option could you possibly have? What is the inflections? Good guess. Not exactly. I mean, kind of. Not what we mean by an inflection point is a second derivative item. It's not really an inflection point in the same way that we use it in calculus. Something does change though. Something does change. It's not increasing. It's not decreasing. What is your only other option? If you're not going up and you're not going down, yeah, 0, right? It's sort of neutral, or you can say it is flat. It's flat. At those spots, f of x is flat. And there are many different ways we can be flat. We can be flat with a maximum right here. We can be flat with a minimum right here. Or we can be flat doing something like this. Flat like this. Or, the other way. F of x, when f prime is 0, f of x is flat. Or it could just be horizontal. Here it's 0 everywhere, right? 0, 0, 0, 0, 0, the whole graph. The whole line, the derivative of this flat line is 0 everywhere. So that is what the derivative tells us of graphs. Right? This is visually what it means, and then we know algebraically how to calculate it, right? You do the derivative, you test for your critical values, right? These f of prime is 0. These are what we call the critical values. Critical values, where the derivative is 0. Right? Those are the spots where the graph is doing something interesting. Some transition occurs. Some transition from going up to going down to going up, or kind of this flat little weird change here. Or if it's just like straight flat 0, right? That's another way. But these some transition, some flatness is occurring, and you have your derivative equal to 0. So the first derivative test is all of this. You're testing where the graph is going up, going down, what the shape of it looks like. This information we get from the first derivative is what is happening to the graph, like where the graph is going. First derivative tells us where the graph is going. F prime tells us where f of x is going. Sort of a direction, right? Sort of the direction of f, like a direction. F prime tells us where f of x is going. Where is it moving? Are we moving up in the world? Or are we moving down in the world? Or are we flat? Are we like some peak, some critical value, some spot where we're 0? Right? And so with this first derivative test, what we can determine is these critical values. We can determine some maxes and mins. We talked about the max and mins, right? If the first derivative test for maxes and mins. We can also test for max and min, right? So, thank you, Perry. So yes, Rowan makes his clothes very wet, so a lot of laundry is necessary. The first derivative test for maxes and mins. If f prime transitions, or changes, I should say, changes f prime of x changes, or I like the word transitions. Transitions from positive to negative, f of x is a what? F prime is transitioning, so we know that there's a spot where f prime is 0 right here. There's a spot where f prime is 0, and f prime is transitioning from that spot. It is transitioning from a positive area, from the positive area, down through the 0 to the negative area. What is happening at f in that spot? It is a what? We talked about these finding maxes and mins. So if we go from f prime is positive, transitioning through the 0 to the negative area, then what kind of situation is f in? Is it a max or a min? Which one are we doing? From positive to negative. F prime transitions from positive to negative. Is it a max or a min? Positive. With your hands, you can think about what f prime is doing. F prime starts positive. So which direction is my graph going with my hand? Which direction is f going? If f prime is positive, which direction? Down? Up? F prime is positive. So if f prime is positive, our graph is going up, right? So we are transitioning from a positive f prime through the 0 to a negative f prime. From positive through a 0 to a negative. So what is that? It was positive, yeah, positive, then it's 0, then it's negative. So is that a maximum or is that a minimum? Maximum, yes, right? Do that with your hands. Really, it's a helpful thing. It is a maximum. If f prime transitions from positive to negative, right? Increasing graph to decreasing graph, then f is a max. If f prime, similarly, if f prime transitions from negative to positive, f of x is a min. Right? From negative, we have another transition. We're in the negative zone for f of x, f prime of x. The derivative is negative. We transition from the negative to a 0, and then that 0 goes up into the positive zone. So from negative to positive, we are at a min. Look at our hands, right? Our hands are moving from negative derivative to 0 to positive derivative, right? So that's a min. Do that with your hands, Jessica. Do that with your hands. Really get into it. Positive derivative, 0 derivative, negative derivative. Right? Negative, 0, positive. We look at the shape of what the curve is doing. And the third situation is if f prime of x does not change sign, we have neither a max or a min. So if the derivative does not change sign, what do I mean by that? So let's look at it. Let's look at some graphs. So if f prime changes from positive through the 0 to negative, that's a maximum. If f prime changes from negative, make that graph a little bit bigger. No, you know what? Let me do this. Negative to 0 to positive. Here's f prime. We're changing through the 0. We have a a minimum. Maximum here, minimum here. If f prime does not change sign, we could have something like this, where we have f prime going positive, touches on the 0, and then remains positive. This is what the derivative graph could also do. Right? Our derivative does touch 0. We do have a critical value right here. That is a critical value, but the derivative graph does not change signs. We go from positive, and we're staying positive. So positive, flat, positive. That would look like positive, flat, positive. Would look like that, right? In the f graph. Positive, flat, positive, right? Going up, we have flat spot, and we go up. Not a max or a min, right? That's what that would create. This would create from negative to positive, a minimum. And this would be positive to negative, a maximum. So this is f, this is what f is, this is what f is, and this is f prime. So what I'm trying to do is get you to like understand the shapes of graphs, right? If we look at from the derivative to the function, how do we transition here? And all of this was our first derivative test. This information about the shape of the graph, what is going on in these situations. Again, probably conceptually a challenging situation. Why you got to spend a lot of time on this. This is why your spring break assignment is going to be related to these kinds of things. Understanding these graphing situations. Okay? So that's all the first derivative test. Let's talk about the second derivative test, f double prime. All right? F double prime. What am I doing here? First derivative, let's do second derivative. Second derivative. F double prime. So let's talk about what is happening when the second derivative is positive or negative or changing signs. What we know about the second derivative. So first of all, f double prime tells us, well, let's just here. Let's take a look again. How did I do this before? All right. So if f double prime, if the second derivative of x is less than, starts greater than 0, then what does that mean for f of x? Right? If f double prime is positive, the second derivative is positive, what does that mean for the graph of f? What does that tell us about the graph of f? So again, the second derivative, I'll do that in green, f double prime, is in the positive zone. Second derivative is somewhere in the positive area. What does that mean for f of x? Did you watch that video? Do we remember what the second derivative tells us? Well, let me show you. This is increasing concave. Yes, concavity, right? So f prime of x tells us about f double prime tells us about concavity. So if f double prime is positive, f is concave. Call it concave up, and that looks like this. Concave up, meaning the graph is a U. Positive U, like this. f is concave up if f double prime is positive. It means that f prime is increasing. F prime of x is, let me do this, is increase. Do this in red. It also means that f prime of x is increasing. F prime is going positive. But the main thing is here we have our second derivative is positive. We have a positive concavity. So concavity is, the U's, like little cups. You can imagine cups, right? The positive concavity gives us a positive U. And if f double prime is less than 0 or negative, then that tells us that f of x is concave down, shaped like that. In the shape here, right? So if f double prime is in the negative zone of the graph, then f is concave down, changing like that. And here also f prime of x is decreasing. So we have all this information about graphs, right? F prime would be decreasing. All this information about the graphs from these derivatives. Visual sort of information telling us about the curving of the graphs, the curvature of the graphs, concavity of the graphs. I think in the video he said concavity. I like concavity. Maybe because I've had so many cavities, I don't know. So double derivative, the second derivative tells us about the concavity, the shape of the curvature, right? The curving up, graph concave up, and graph concave down. These like general, like the curvature shapes here. What about if f double prime is equal to 0? What does that tell us about f of x? Is what? Whoopsies. Is what? F of x is doing what when the second derivative is equal to 0 at those 0 locations. Now my second derivative is touching the x-axis. F double prime is on the zeros. What is happening in f of x at those locations? What is the graph doing when f double prime is on the zeros? At that location, something special is happening. Some transition is occurring. Just like in f prime at 0, a transition occurs. When we are equal to 0, these transitions happen. So what transition is happening when f double prime is 0? What is the graph doing? Party, so I said it earlier. Yes, a point of inflection. Inflection. We call that a point of inflection. And it is the locations where the curvature changes. Right? This is the transition. You are transitioning from concave up to concave down. You are transitioning from, let's see how to do this, like here to here. Right here is where the curvature changes, right? You have a cup like this, and then you change, you're going down, or the other way. You have a graph that's going concave down, and then you stop going concave down, you start going concave up. Whoa. Keep it. It's those points of transition where you were concave down, and then you stopped, and now you're concave up, like your cup shape is changing. Your concavity is changing at these transition points called a point of inflection. That is what a point of inflection is when the second derivative is 0. When the second derivative is 0, you have these points of inflection. And this is our second derivative test. This is the information we get from the second derivative. The curvature of the graph, the shape of the graph, right? So f double prime tells us the curvature or concavity, curvature or concavity of f of x. F double prime told us what direction the graph is going. F prime told us the direction. F double prime tells us the curvature, the shape of the curve of f of x. And there's also a second derivative test for max and mins. Test for max min. If f prime equals 0, we have to have the derivative equal 0. There's no max and min if the derivative is not 0. And f double prime is positive, then f is a what? Max or min? Which one? Let's think about this curvature. So now we have another test for maxes and mins we could do, called the second derivative test. If the derivative is 0, right, has to have the derivative 0, and the second derivative is positive. So one of our critical values, the second derivative of that critical value, where f prime is 0, the second derivative is positive. Positive curvature. So we have a flat spot, right? We have a flat spot for our derivative is flat, and the curvature is positive. So is that a max or is that a min? Max or min? I'm looking for maximum or minimum. Flat spot on the graph, right? The graph is flat. F prime is 0 tells us the graph is flat. And my curvature is positive. Parisha thinks that's a min. Jessica thinks it's a max. Positive curvature, does that look like this or like this? Positive curvature, positive concavity. A U or an upside down U? Yeah, so it's not this, so it's got to be this one, and that's a minimum. You're testing your concavity, right? Positive concavity, and your curvature is positive. You have a minimum. Yeah, it's a little weird to have, well, if it's positive, you'd be a maximum, right? No. Second derivatives don't work that way. Why? You got to be so complicated, second derivatives. Positive curvature, your graph is going to be like this. Flat spot and positive. And similarly, if f prime is equal to 0 and f double prime is less than 0, f double prime of x is less than 0, or we have a negative, then f of x is a maximum, right? Because then we have a negative curvature, negative concavity, downward concavity, and so we have a maximum. So this is the second derivative test, figuring out from we have a flat spot, we know what the second derivative is at that location, at the same location, right? In that particular location, there is a flat spot. In that particular location, there is a negative second derivative. At that flat spot, we have a negative second derivative. We have a maximum. What if f prime is 0, oopsies, f prime of x equals 0 and f double prime of x equals 0? What do we have then? Well, it's going to be neither, again. But what is that going to look like? Oh, what if both are 0? Interesting situation. Yeah, it is a point, right? It is a point. What is happening at that point? It's a flat spot. The derivative tells us it's flat. Right? The derivative tells us it's flat. The double derivative being 0 tells us what is happening at that spot. It's flat, and what else is changing? It's flat and the inflection point, exactly, right? So we change from curve up to curve down. So we know it's flat, and we know we have to go from like positive curvature to negative curvature. So we have a flat spot like this. Or maybe it would look like negative, positive, like that. Right? If f double prime is positive over here, or negative then positive, we have these special little like a cubic function has this shape, right? Y equals f of x cubed has this shape. Lots of other graphs kind of have this S shape here. But it's neither a positive nor a negative. It's not going to be a max or a min because the transitions aren't happening in the correct ways. Yeah, it's an inflection point, and we change from positive to negative curvature, right? Positive to negative curvature at this transition point. So there's some special interesting locations of these graphs. Right? And this is our second derivative test. So we can use this information now to figure out the shape of a graph from its curvature, from the information given in the derivative and the second derivative. We can use this information now to determine shapes of graphs given maybe given the function. We can maybe figure out what does the derivative look like. And then what from the derivative we can look at what does the second derivative look like. So we can get some pictures of these graphs now that we have this information. We can use that to sketch some curves. So we're going to do a little curve sketching. We're going to try to use the information we have about the first and second derivative. Use the information that we know. First derivative tells us direction. And where the spots are flat. Second derivative tells us curvature and when there are points of inflection. Right? Points of inflection and curvature. In the first derivative tells us directions, increase, decrease, and flat spots, maxes and mins and critical values. Okay? So direction and curvature. Let's take a look at some graphs. And see what we can do to interpret some of these situations. All right, everyone got these notes? Can I move on? Let's move. Check it out, everybody. Here we go. Here are some graphs. I gotta move out. So I have some functions here and some derivatives. The blue are the f's, the purples are the derivatives. I want to match the function with its derivative. So let's start with A. Start with this one here. Let's try to draw the derivative of A with what information we know about A. Let's just focus on A. So everyone sketch this graph out of A here. This curve like this. Notice there's no values. I don't really care about the specifics, but make sure it crosses at 0 here, and we have, you know, a max and a min, like this kind of shape. So let's try to draw the derivative of A. Let's try to draw the derivative of this graph. Draw the derivative, right? We're looking at function, looking at functions, not graphs now. Visually draw. Again, we're looking at the whole graph, trying to determine the derivatives, what's happening in the whole picture. We got this graph drawn? Okay. So the first thing you're going to know when you're looking at a derivative is where are the zeros. First, find the zeros of f prime. And those are the flat spots, right? So there's going to be a 0 right here. So there's a 0 right there and a 0 right here. So I know that f prime is going to cross right here on the x-axis. I know that this flat spot here is going to make a 0, and this flat spot here is going to make a 0 in my derivative graph. I know that it's going to cross the line. I don't know if it goes this way or it goes this way, but it's going to cross right here. And it's also going to cross right here. It's going to cross this way or this way right here, because that's a flat spot. Flat spot, right? I know that flat spot is going to cause that. And this flat spot is going to cause that, right? So we have these two flat spots we're guaranteed to have in our derivative graph. Second, find the positive and negative f primes. Where is your function increasing and decreasing? Where is your function positive? Where is f prime positive? And where is your function decreasing? Where is f prime negative? So in the section here, from here to here, is f prime positive or negative? Which one? Paris says negative. Right? The direction of the graph, pointing down. Pointing down, yeah, it's going to be negative. We're going downward, right? So since my derivative is negative, right there, I mean, erase all this other stuff, right? Again, we're just looking for the shape of the graph. We're looking for the graph. My derivative graph is going to be down here, right? Hold on, right? It's going to be down here. F prime is going to be negative. It's going to be down there in that direction, right? So I know it's going to look something like it's going to be negative, and then it's going to be, maybe it'll be like this, negative, and then from this point to this point, this section here, f prime is positive. We look at our graph is increasing now, right? We're transitioning from a negative to a positive, right? So my f prime is going negative. It hits the 0. We are now positive. At a certain point, I have to change directions and go down to the bottom here, right? I have to change directions in my f prime graph. At a certain point, right? I'm going positive, right? I'm going. The derivative is negative. I hit the 0. My derivative is positive. I need to at some point change directions and start going down. I'm still positive. Notice that this area here, f prime, is positive because I am above the x-axis. I'm maximally positive here. I'm a little bit positive here. I'm a little bit positive here. But this entire area is sections where the derivative is positive, where the graph is increasing, right? We're like a little bit positive here, very small amount of positive, like a small amount of positive, and more positive, more positive, more positive, and then less, 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 very small amount of positive. So we're a small amount of positive, and then we're going up to the maximum amount of positive, and then we go down less positive until we reach the 0 right there. But this entire section, f prime, is above the x-axis. And that's all that matters. It doesn't matter if it's going up or going down, it's positive. Our graph increases from here to here. F prime is positive in that entire section because the graph is increasing, right? Trying to show you these tricks here. So from here to here, we are positive, and then our graph is negative. Our derivative is negative again. Now we're going down like this. Derivative becomes negative again. So in these sections, right, if you imagine these sections here, here f prime is negative. Here f prime is positive. Here f prime is negative. We're looking visually at the transitions, right? Negative f prime, because the graph is decreasing. Decreasing means it's negative, right? We're very negative up here, very negative. We're less negative as we go down to 0, less negative as we go down to 0. And then we're positive, maximally positive, down to here where we're back to 0. And then we go negative again as our graph decreases, right? Our graph increased here, a little bit positive, more positive, a little less positive, above here. And then we're negative down there. So you're finding your zeros, and you're determining where f prime is on the upper half of the graph, right, above the x-axis, or below the x-axis. Right? Positive, you are above the x-axis. Negative, you are below. And that's it. Those are your determinations, right? Are you above the x-axis, or are you below the x-axis? Are you positive? Is your derivative positive, or is your derivative negative? And that's our derivative graph. So let's look, and that looks like it's going to be, there you go. Positive zeros, these two 0 spots, and then your negative graph. And if you want to think about this algebraically, another angle that you can use to determine if you are correct or not, another angle you can use, aside from looking at your 0 spots, right? Check your zeros where your flat spots are. Check your positive, negative, decreasing, increasing. Another angle you can use is algebraically. Here, f of x is clearly a cubic function. It's something cubed, right? We have 1, 2, 3 curves. This is some kind of x cubed equation, f of x. And if we take a derivative of the x cubed equation, here f prime of x, well, this has just got, it's just a parabola. This is some kind of x squared equation, right? We got a cube equation. If we do a derivative of a cube equation, the power rule says you bring the 3 down, you make it a 2. So a derivative of a cubic equation is going to be a parabola, parabolic equation, a quadratic equation. So that's another way, another angle you can use to check your derivatives. Look at a function. Oh, that's a 4th degree polynomial. I know if I do a derivative, it's going to have to look like a cube. Or if you have a cube, I know the derivative has to look like a squared, like a parabola. So it's a good way to check your derivatives, check your information. All right. Let's try another. Can I clear all this? How do I do this? I guess I can leave it. It's fine. Let's look at, I don't know. I want to do B? Let's look at D. D is very similar to what we just did in A. So draw yourself, everyone, draw yourself this graph here. We're going to do D here. See how much. Yeah, great. Draw yourself this graph. Again, there's no numbers. Just make it sure it goes up, maxes out, flattens at 0 again, goes back up, and then down. So I would like to have someone try this for us. I'm going to enable annotation, and that means that someone can draw on the screen what they believe the derivative would look like for D. So do I have any volunteers? Who should I call on? Let's see. Let me randomize it. Let's do a random number here. Where's my random number generator? Random number generator. Okay. From 1 to, let's see how many people are here. 1 to, where's my 17? Let's see if I can do a random number here. Hold on, let me go to Google. Random number generator. 1 to 17. We're going to get number 5. 1, 2, 3, 4, 5. Stephanie, you get to give it a try. Oh, goody. Use the annotation tool. Does the annotation tool work for you? You know how to access the annotation tool? Click on more, click all those things. First, determine where does the derivative touch the x-axis. Find the zeros of the derivative first. Highlight those locations, Stephanie. Where are my zeros? Good, one is there, for sure. There's 2 others. Where else is there a 0? Oh, good, yeah, red, excellent. Okay, yes, good. So put those zeros on the x-axis. Right, because we're drawing the derivative graph. So put the zeros on the x-axis. Yeah, those 2 spots. So we have a derivative, a 0 derivative. Yeah, great. There, and there, and there. Perfect. All right, so those 3 spots, the f prime graph is going to cross the x-axis, or at least touch the x-axis in those locations. Now, what does the graph of the derivative look like in the first half, in the section over here? Is your derivative coming from above, going down, or is your derivative below, going up? What is this section of the graph? Is your derivative of this section positive or negative? What is the direction this graph is going? So do you come from up above, down below, or do you go from down below towards a positive? Like draw what you think your direction is. Good, exactly, right? You are coming from a positive side, right? Your derivative is increasing until this location. And then we go negative derivative, until this spot here. So you're going to go negative to here. And then what do you do after that? Yeah, do you go back up? Well, this is definitely increasing, right? This is a positive section here, right? We're negative, right? The graph is going down. And what's the graph doing over here? It's increasing, right? So we're going to go positive, and then we have to come back down to touch here. Very good, exactly, Stephanie, very nice. Something like that. Positive derivative, down to 0, negative derivative for a section, and then 0 here, and then positive again, because we're going up with the graph, positive, and then back down to 0, and then negative derivative, keep going negative, right? 0, and then negative derivative after that. Graph decreases. And again, you can think of it like, again, the other angle you can attack this with is your information about the polynomials. Yes. Why is this above here? So the graph, thank you, Stephanie. You're all set. The graph here, we have positive derivative to 0. Positive derivative to 0, negative to 0, positive to 0, and then negative, right? Let me clear the annotation so I can see the graph. Whoopsies. I gotta do it. Stop it. There we go. We have a 0 here at that location. We have a 0 here, and we have a 0 here. Then we go from positive. So why is this above here? Why is this here? If this is f, what is f doing in this section here? Is f going, is it increasing or is it decreasing? F is increasing, so f prime is positive. F is increasing. It doesn't matter that f is negative, like f is in the negative zone, right? It doesn't matter where we are. It matters the direction we're going. The derivative is the direction. And our direction is positive, going up. So if our direction is positive, my derivative has to be up high. My derivative has to be a positive number. My derivative has to be a positive number, so we have to be above the x-axis. If my derivative is positive, I have to be above the x-axis. And I am very positive until I reach this 0 here, and I get less positive, and then I'm 0. Very positive, down to 0. Right? Highly increasing until we increase no more. Highly positive until we are 0. Highly positive until we're 0. And then we are a decreasing small section here. All of this stuff down here, in this section here, f is decreasing, so f prime is negative. We're in the negative, we're below the x-axis. F prime is below the x-axis here, right? F prime is below the x-axis. So that's why, right, we know that the derivative is negative in the negative zone. And then again, our derivative is positive, going above the x-axis, positive in this section here. Positive derivative. And then we reach a 0 again right here. Positive, 0. And then we're negative, we're decreasing our x. So the derivative is all about the direction of the graph, right? The derivative tells us the direction. Okay? So we're out of time. Here's what your assignment is going to be over the break. We're going to do Khan Academy stuff. I'm going to have you do a few sections. Let me show you what I want you to do. We're going to get a little more practice, like understanding the derivatives, the positive, negatives, how this all works, and these graphs. So let me show you.